Write 84 as a product of its primes. So we do our tree diagram. We put 84 in and then we're going to find the prime factors and we need to circle the prime factors. So I'm halving 84 and I'm doing 2 times 42. Then I'm going again and I'm going to do 6 times 7 is 42. And 7 is a prime number, but I need to go again with my 6. 3 times 2 is 6. So there are my prime factors of 84, but now I need to write it as a product. We're not done yet. So 2 times 2 times 3 times 7 will get us the mark. If you prefer, you can write it as 2 squared times 3 times 7. Just choose one of those two. Find the lowest common multiple of 60 and 84. So I've brought over my factor tree. I just need to work out my prime factors of 60. I'm going to go 6 times 10. And then I'm going to go 3 times 2, and they're both prime numbers. I can circle them. Remember, prime numbers are numbers with only 2 factors, the number itself and the number 1. And then 5 and 2. Circle those. So my product of my prime factors, not that I need to do this, I'm just going to write them out, are those ones. Okay, so I now need to put the ones in the intersection, the common ones in the intersection. So I'm going to cross off 2 and 2 from there and pop it in. Then I'm going to go again. I've got a 2 here and a 2 here. I can put that in. And then I've got a 3 and a 3. I can put that in. And I'm left with my 5 from my 60, which needs to go here, and my 7 from my 84. Now, when we find our lowest common multiples, we are literally scooping everything up that's in this Venn diagram and timesing it together. So I've got 5 times by 2 times by 2 times by 3 times by 7. So I'm going to, first of all, do 5 times 2 is 10. I'm going to do 2 times 3 is 6. And then I can pop my 7 on the end. And now 10 times 6 is 60. 60 times 7, well, 6 sevens are 42. Times that by 10 and we get 420. Our next topic is probability. And to think of probability, if we draw a number line with 1 being 100%, this is going to happen, 0 being it's not going to happen. So all our probabilities must add up to 1. Amanda has two fair 3-sided spinners. She spins each spinner once. Complete the probability tree diagram. So each one has got 3 sections, 1, 2, 3, 1, 2, 3. So spinner A, if it lands on 2, there's only 1/3 chance of that happening because there are 3 parts and there's only 1, 2. Okay, does not land on a 2. Well, we've got a 1 and we've got a 3, so that's 2 out of 3 chances. Spinner B lands on a 2, again, just 1 out of 3 chances. Does not land on a 2, that's 2 out of 3 chances. 2 out of 3, and then we repeat that again, 1/3 for landing on 2, 2/3 for not landing on 2. Finally, work out the probability that spinner A lands on a 2 and spinner B does not land on a 2. So we multiply across the branches. We want spinner A landing on 2. So here we go there. We've got 1/3, and spinner B not landing on 2. So that's not landing, that's 2/3. What we need to do now, our last step, is a multiplication. 1/3 times by 2/3, and when we multiply fractions, we just multiply the denominators and the numerators together. So our numerators, 1 times 2 is 2, 3 times 3 is 9. That's our final answer. Combining ratios. This is a grade 5 question. It will be right at the end of foundation or at the beginning of higher. And when we combine ratios, we need to look for 2 of the parts of the ratio that are the same, and we combine them so we can basically get rid of one, cancel one out. Our question: there are only blue pens, green pens and red pens in a box. The ratio of number of blue pens to the number of green pens is 2 to 5. The ratio of number of green pens to the number of red pens is 4 to 1. Let's worry about the last part of the question later. First up, I need to combine my ratios. Green is the same, so I'm going to make green the same. I'm going to times my 5 by 4 to get 20. So I'm going to have 20 green pens. And I'm going to times that by 4 to get 20. Whatever I do on that side, I do to that side. I've now got 8 blue pens. Now here, to get 20 green pens, I need to times by 5. And whatever I do to that, I have to do here. 1 times 5 is 5. Now I can just get rid of this one here. I don't need this one anymore. So I'm going to rewrite my ratio. Blue to green to red. So I've now got 8 to 20 to 5. That's our first part. Now we come to the last part of the question. There are less than 100 pens in the box. What is the greatest possible number of red pens in the box? Okay, so I'm going to times all of these numbers up together. I could times by 2, but I won't get very far. So I'm going to times everything up by 3 to see how far I get. So 5 3s are 15. So I've now got 15 red pens. 3 times 20 is 60 green pens. 3 times 8 is 24. Now, there are less than 100 pens in the box, so if I now add these numbers and check how far I am away from 100, 4 and 5 is 9, 2 and 6 is 8, add 1 is 9. I'm really close. I can't go any further, which means the greatest number of red pens in the box would actually be 15.